Okay, so for today, we are going to be diving further into Python and getting into object-oriented programming, as I'm sure was probably fairly obvious from the first video that was dropped for the day. And I hope everybody got a chance not only to review it, but what I marked as optional for what's an adventure game, because that's what you'll be dealing with today. So if you haven't already seen the one about the adventure game, you might want to watch it before you get going on the repo for today. Just as a note, the repo for today is the part 2 repo. And it will cover Wednesday, today, and tomorrow. Of course, you'll have your sprint on Friday. So I guess the first thing I've got, and I'll just kind of open up the floor based on what you already know, based on intuition, based on the video, why might we use object-oriented programming? We covered this to some extent with JavaScript, and of course, JavaScript is not truly an OOP language. But what are some reasons that we may use object-oriented programming?
I think the video said something about like it allows you to have multiple inheritance. So you can like a class can inherit from multiple classes, I think.
Yeah, you can inherit, well, depending on how you're using the term, you can have a parent, and then you can have a child, and then you can have a child of that child, and the child will inherit all the way up the chain to the parent. And you also, yes, as you're speaking of, can inherit from multiple classes simultaneously. And so with that, with being able, with the inheritance that you speak of, being able, having that linear inheritance, having the inheritance being able to be dynamic in the fact that it can inherit from multiple classes, what's a general theme that you're looking at there that object-oriented programming lends itself well to? Two things I'm thinking of, actually. Remember, we like to break problems down into smaller problems, and with OOP, you get a very modular approach to the program. So as we're talking about the different classes that we've got, the inheritance, you're able to take your problem, break it into a smaller problem, and that's nice. And kind of hand in hand with that, classes can be reused very easily. Making it modular makes debugging easier in general. It makes testing easier in general. It makes maintenance easier in general. It's an extension of the idea of not creating the spaghetti code and having clean, organized code. If you remember, like some back in JavaScript, the breaking things down into various functions, if you could break things down into smaller functions and incorporate that tends to lead to the same thing: easier debugging, easier testing, easier maintenance, easier readability. And just kind of another general advantage of object-oriented programming, it allows us to abstract away details. So we can use objects and other classes without needing to know all of the details about how functions are implemented. So even though getting your head wrapped around it can take a while and it can be difficult in implementation at first, it really leads to a lot more simplicity, or simplicity relatively speaking, down the road for a wide variety of things. And I think we'll start to see that today with the GP that we're going to do, the programs that we're going to go through together, and you will see that in your adventure game for the next 2 days in your independent project. So that said, does anybody have any questions about the videos that we watched this morning? The ones that were for today are the object-oriented design and the what's an adventure game, the ones for tomorrow are the class inheritance and the class association. Were there any questions about these two? Mostly about the object-oriented design, because we'll get into the adventure game a little bit more as we're wrapping things up and we start talking about what your assignment is for the next 2 days. Anybody, anything? Okay, that said, what we're going to do kind of to introduce programmatically the classes is we're going to create a store, and we're going to create kind of a simple representation of an inventory for the store that we are going to call categories. So logically, if we're going to have a store and we're going to have, let's say, different departments or different sections of that store, what would we probably want to do for each of those? Think in terms of the video and what we've just been discussing. But if you're going to have a store, if you're going to have subcategories in that store, what might we want to do to get started with a program?
Store is going to have employees, products.
Yeah, that's good thinking. I wasn't real. I meant more programmatically. What would we want to do with the store? What if we wanted to? We might want to create other stores down the road. So, what would be something easy to do for the store?
Create a class.
Yeah, I'm going to create a class for it, and that's what object-oriented programming, relies very heavily on. In Python here, we will rely almost solely on classes. When you get to data structures and algorithms, you're going to be putting those together with classes. So definitely start thinking in terms of classes. Right here, we're trying to really do 3 things at once. We're teaching you how to learn a new language. We are learning Python specifically for the purpose of learning a very relevant language in today's world of software development, and we're teaching the concepts of object-oriented programming. We could do any of these as a standalone type thing, but we're combining all 3 of these things kind of to maximize, kill several birds with one stone, if you would. So yeah, we're going to make a class, and the first thing I'm actually going to do, because the way that the code goes along, it doesn't really make a lot of sense. So think about it. We're going to have a store, and within that store, we're going to have we're going to call them categories. It could be a department, whatever you want to think of it as. I'm going to make the category class first, simply because the store class isn't quite as intuitive without the category class. So I'll just say the Python terminology for it is simple. You just say class and you name it whatever you want to name it outside of the few reserved words that there are. Capitalize it as I did, and do not forget your colon. And then, of course, you are going to indent in, and we're going to have our init that you will see always. So to initialize this class, we always have self in Python with classes. We're going to take in a name as well for the category.
Hey, Jonathan, can you increase your size?
Better?
A little bit more. Thanks. That's good.
So we will say self.name equals name. Anybody want to talk about what we're doing with self, why we're using self?
Are you making a class variable with that? Like that's what self is doing. Like it's a variable that's going to be used in the class.
Well, the name is there. Basically, there's 2 parts of a class. There are the attributes. This is an attribute that we're making of the class, the name. So we're invoking it with self.name, and it's simply the name that we're taking in as an argument. So when you instantiate this class, when you make an instance of this class, as you're going to see later on, the self is simply referring to the parent. So the self allows you to access everything that was on the parent. So the methods that we can methods or functions that we can define within the class. Just think about it, like I said, this is an attribute. An attribute is something referenced to as fields or properties. They're typically nouns or adjectives, and they describe characteristics of the thing we're modeling. So we're modeling this category, this department of the store here. It's going to have a name. So the function is, if you think about it, an action that can be taken. So right here in the category, we're not going to have any of those, but think about, let's say in this term, an individual department may be able to add a product. Somebody mentioned the different products that department may have. You could have a function that allows you to add a product. So just think about when we're initializing, when we're instantiating the term that we use, that class, an instance, instantiating an instance of that class. This is coming into play, this init right here that you're always going to see that takes in self. And self is just allowing you to access everything on the parent in terms of that inheritance that we kind of brushed on earlier that we're really going to get into tomorrow. Anybody have any questions about that? And this is kind of generic since we're not going to be adding products, that if someone calls upon this category, we are in this double underscore str that we've got. Basically we're allowing a string representation of the category. It's very easy to return primitives. Any of your typical primitives that you have are easy to return, but if we actually want to return the category, there's not an easy way, because it's an object, there's not an easy way, this class being an object, there's not an easy way that you can just ask, hey, what's in this category? So we're having to create something here that allows you to access, theoretically, the products, and we'll just say no products available in self.name. And this will make a little bit more sense. So that's all we're going to do for the category. You could do this in a separate file. You could name it whatever you want. Remember in Python, say we did this in a category called a file in the same directory named category, and the class was category. Well, then at the top of the next, we would just say import category. Somebody mute their volume that's got it on, please. Shit, I got the syntax wrong. I think it would be from category import. You can do that. From category, import category, and of course it's highlighting this here because there's not a file in the same directory named category. But since we're going to do it all in the same file, we don't have to worry about that. But this is how you would import a class from another file within the same directory. There's ways of getting to it that are outside of the directory, but for now, suffice it to say that that's what we would do. So now we're going to make a store class now that we've done this. So once again, we'll say class store, and we will have the init once again with self that we're always going to have, And then we're going to take in name. We're going to take in categories for the moment. And then the attributes, it's going to have a name and
Need it.
all right, so for the store itself, the store is going to have a name that we can give it, and then the categories is going to be the different departments. As you'll see further on down the code, the categories is going to be utilizing this class. So the whole point of this is to show you how classes can interact. So we also can have this here. We'll just take in self. We'll define output as an empty string. Output plus equals self.name. And we'll add a new line. So that'll be so what we're aiming to do here is we're going to be running all this in the terminal, and we are looking to be able to have some string output in the terminal, as we will see later, and we're going to be able to see the different categories that we create, and we're going to be able to select a category and get information about the category. So right here we're simply making a stringified way of representing the store in the output that we're going to see in the CLI. So we specifically are using this str syntax that you see right here again. We'll cover a little bit more about that in the alternative if you did not use this and tried to call upon the class and the limitations that that would provide. So for here, we're just going to have the name of the class or the name of the store. And then we're going to have an iterator that starts at 1. And then we're going to have to remember the categories. The categories is going to be a list. A list, same as an array like we talked about yesterday. So we're going to be able to want to be able to iterate through those categories because we don't know how many categories we're going to get. So we can just say for C in self.categories, and it will allow us to iterate over the entire list of categories. And then we're going to have our output on a new line. Remember, we added the new line up here on 17. So your output plus equals, and the space plus, we have I, and we just have the str in front of it to turn it into a string. Remember, because it's in an integer format right now. So we're just going to have the number starts at 1. We're just going to number the departments of the store. So string, then plus, a period just to look pretty, and a space mark, plus category.name. Remember up here, we have a name for categories. So each of the categories is going to be an instance of this class. So each of the categories that we see here will have a name, so we can call c.name as we're iterating over each item in the list, each object, each instance of the class that we're going to see, that we're going to instantiate here, and then we're going to put a new line.
Sorry, the C is the category.
What's that?
The C.name is C is.
Oh.
Sorry.
Oh, I think I know what you're asking. So let's see if this makes it clear. And this is why I kind of want to remember we've got categories as a whole class. You're going to see how we integrate when we call the store, we're going to use the category class here to instantiate the categories. So each store has a name that we're giving it, can be whatever. Each store will have the categories that we give to it when we instantiate it, okay? Remember, each category is an instance of this class and has a name. So here, we're simply, this is a placeholder. You can use anything you want. We're saying for C and self.categories, so we're iterating over the list of categories that we have here. That list contains objects that are each an instantiation of this class, the category. And we're just going over each one. And for the output, remember first we had the name of the store, then we're going to go to a new line, and the output is simply going to be the number that we've got here, this iterator that right here, we can just say I plus equals 1, and a period, and then the category dot name, the name up here that we gave to the category when we instantiated it, plus a new line. And this just gives us an indentation that you'll see later in the output. And then we just iterate up so that the next one is number 2 and the next one's number 3. And this just has, as I said, the str in front of it because we're creating a string. So we can't insert a numeral, an integer into that. So we're simply coercing that into a string. Did that answer your question?
Yeah, I just didn't see that we're actually calling it over here.
You what?
I just didn't see that we were calling the C in self-categories over here.
Yeah, you're accessing what you've taken in as an argument here, and you're going to see right below this when we get started with it. This is going to be instantiating this class multiple times to create these categories. And then we're just iterating over that list that we create. And so then we're also going to have an exit option within our printout. Remember, at this point, all we've really got is we're creating a real basic output on the screen so that a user can interact with it. I think it'll make a little bit more sense here in a second. And then we're simply going to say output plus equals, leave that space again, plus add that last number, plus we're going to give an exit option. And then this is just going to return the output. Okay. So after we've got all of this, we're still within the store category. And so if we wanted to instantiate the store, we could name it my store equals. Now, to call the store, we simply call store. And remember, we've got to give this store a name and categories. So for the name, what do we want to name the store? Somebody come up with a name.
Superstore.
What's that?
Superstore.
Superstore.
Yeah.
So your first argument will be Superstore. And now we need to make categories. Remember, we're going to iterate over it. So we're going to create a list here. Now, intuitively, what would we do here for the categories? How would we Remember, we need the categories. I've got the list, so we can iterate over it here, the array. What do we need to do?
Initialize a category.
Yeah. Excuse me. We need to instantiate the category. So how would I do that?
Just like store, category, and parentheses, then the name.
Yeah, so all we need for a category is the name. So we simply give it that, and need to give it a name. Somebody give me a name for a category that's in the Superstore.
Grocery.
Groceries. We're going to make a few categories. So if we need to make a new category, say we'll have, I don't know, electronics, like a Walmart, like someone else suggested we could have done. Pick one more category. I don't know, clothing. And if we just say print my store, go back and look through all this to make sure it looks right. Self-domain class store, categories. We're instantiating the store, we're giving it a list. We're giving each category a name. What did I name this? Python 3. So let's see what happens. We're in the correct directory, so. You see what we've got here. We have got the Superstore, and we have printed out groceries, electronics, clothing, and an exit function. But that's all we do, and it just returns out of the program. So now we want to be able to kind of maybe get an idea now of how classes can be, just like functions could be invoked with inside functions that we did a lot with in JavaScript. You're seeing how classes can be utilized with other classes. And the nice thing with this is think in terms of like a video game. If you wanted to have a class for a player, you wouldn't have to, every time you wanted to instantiate a new player, you simply utilize this class that exists and you give it the name and you give it the age and the size and the life or whatever you need. And say for the player, each player may have multiple weapons. You could have a weapons class. You know, it's pretty much however you want to handle it, but you can see how this works up to this point. And the next thing we want to do here is be able to select from this class or from this output, groceries, electronics, clothing, and get something from it. So what we will put here is we will just say selection equals 0 so that we have something for selection. And we're going to do a while loop. While selection not equal length my store dot categories. And we want to say +1. So what this is doing is while the selection is remember here, so we made the length of the category 3. So we had 3 groceries, electronics, clothing. And what this is doing is if they select 4, the length of this is 3. So if they select 4, it's going to invoke that exit and exit out of the program. So this while loop allows you to select categories within the store until somebody, in this case, inputs 4. Maybe if we had 5 or 6 categories here, then this number would be different. But it's a variable statement here to take into account this exit. Is that clear to everyone? So while that happens, while this is the in here, so I just didn't like that. We're going to say selection equals, and we're going to allow for an input. And this input is simply going to prompt the user, and it's going to say select the number of a department. So all this is doing is this is going to create a prompt that allows a user input. It's simply Python syntax. We'll see that in a minute what it does. And it's just going to say select the number of a department, and we're going to be able to pick 1, 2, 3, or 4. If we pick 4, it's going to kick us out of this while loop. We'll be able to select from these few departments that we've made as long as we're selecting within the department. We can put in a try here. First thing we're going to do is say selection equals, and we're going to cast it to an integer. Remember, when somebody inputs this, it's going to actually, even though you're touching the number keys probably on your computer, it's going to input it as a string. So we want to cast this into an integer. So somebody puts in 1, it's simply going to make that 1 the string into a 1. All we're doing there. And we're going to say if selection equals length of my store dot categories plus 1 print, we'll say, what are we going to say? Thanks for shopping at Superstore. Then we'll have an elif selection is greater than 0. We don't want the selection to be 0 because remember we start out at 1 here. So if the selection is great. And selection is less than or equal to the length of my store dot categories. So basically for this case, it's going to say, hey, if they put in a 1, 2, less than or equal to the length, remember the length of the categories is 3. So if it's a 1, 2, or 3, if we're selecting a department within that store, a category within that store, the elif, we will say print my store dot categories, and we will simply say for the index selection minus 1. Why do we have selection minus 1? Why do we have selection minus 1?
because index start from 0.
Yeah, the index started from 0, but remember we up here,
But our grocery store categories start from 1, 2,
correct.
3.
Exactly what I was looking for. That's all that I was looking for, is we're just simply correcting for
I think you forgot to closing as 32.
good call. I was looking and looking and looking, and I didn't even bother to look up at line 32. I was looking for line 33, but thank you for that catch. Good. Perfect example of things that I do quite often, where I'll miss one single character and throw everything off. But like I said, anytime anybody just outright sees something that needs to be addressed, or sees me fumbling around looking for what the error is, feel free to speak up, because it's certainly not me trying to test anybody to catch it. It's me trying to figure out where I messed up. So we have the if selection equals the length of my store.categories plus 1. So that's just accessing the exit, whatever number the exit is. Then we're just going to print thanks for shopping at Superstore. And remember, because this while loop, now that the selection is going to be the length of the store plus 1, the while loop will terminate the next time we try to loop around to it. Or if it's between here, we're going to print my store.categories. Remember, the categories is that list, and we're simply giving it an index, and we're going to return, remember up here, simply no products available here, because we need a placeholder and we don't want to get more complicated at this point. And then finally, we'll have an else. And this, what would the else catch here? Why would we have the else? We got everything covered. We got if they picked any of these. We got if they picked these. What's the else going to do?
When they pick anything outside of their name?
Yep. If you pick an invalid number, we'll just say, please select a valid number. And then outside of the try, and this is just going to catch if they don't put in a number. And we can just say, and we've got it, and it's saying, please select the number of a department. So if I put in 0, please select a valid number. Stupid. At 0, we get please select a valid number. If we put 5, please select a valid number. If we put 1, no products available in groceries. 2, no products available in electronics. 3, no products available in clothing. 4, kicks us out of that wild loop. Thanks for shopping at Superstore, and we are back to our command line. Questions about what we just did? Certainly there's got to be something. Multiple classes, classes interacting with classes, instantiating these classes, maybe some new Python syntax that we saw here. I'm going to drop this code into the channel.
Yesterday I was looking at this. Wait, can you guys hear me?
Yeah, I turned my volume up. I think I can hear you better now. What's up?
So are we not going to use like the super method in any of these, or is that not like?
We'll talk about that tomorrow.
Okay.
You will, absolutely. You will. Tomorrow gets a lot more into the inheritance. Today's just kind of an overview and learning how to create classes, how to work with classes. Tomorrow is going to be the products. We're going to use the same code, and you're going to have the products that I spoke of today. So each store has departments, the categories, each category, each department has products. And we're going to use class inheritance, class association, and introduce a lot of new terminology. You need to watch the two videos, the other two videos that were in the channel that I posted for that. But yes, you absolutely will be using it. That should be the code right there.
Sorry, where's the part where it says like select the department number 4, where it brings you back to it lets you exit out.
Okay, so you're asking how we're able to exit out.
Yeah.
Okay, so we have a while loop. So because remember how we've got this exit that's number 4. We up here we created the output that was, we had each class. So we had 1, we had 2, we had 3, because we had 3 categories. So however many categories there are, the next number is going to represent exit. And we've just got that in our output. Okay. So in this while loop on line 29, we simply said while selection is not equal to the length of the store categories, 3 in this case, plus 1. So so long as somebody doesn't enter 4, this while loop is going to keep running. So if they're not entering 4, they are it's going to either catch here, where if they do enter 4, it will, when they enter 4, because remember the input happens after the while loop. So whatever they put in the input, if they first thing it looks for, did they hit exit, in this case 4. So if the selection equals the same thing we did up here, length of my stores.category plus 1, it prints thanks for shopping at Superstore. Of course, it skips all of this. It goes back up here. My selection was 4, so the while loop terminates. We have thanks for shopping at Superstore, and we completely exit out of the program. Or it goes down here, and if it was, in this case, 1, 2, or 3, if the selection's greater than 0 and it's less than the length of my, or equal to the length of my store. So this is catching it if I put in 1, 2, 3, 1, 2, 3, 4, if I've got 4 categories, 1, 2, 3, 4, 5, if I got 5 categories, then this would be 6, catching the exit, and it prints my store.categories. It prints whatever we've got here. Remember, we've simply got a return of no products available in the name of the category. And it's just accessing that by the index that we've established here in each instantiation of the category for each name. Else, if it's a 0 or if it's greater than in 4, if it's greater than the exit number, it's going to just loop back around and say, please select a valid number. And this except just catches if they don't enter a number. So let's say, run it one more time. And if I said, it's going to say, please enter your choice as a number. And then if I say 4 exit, thanks for shopping at Superstore, and it exits. Does that answer your question?
Yeah, thank you.
Yeah. So up here, if we went and we added another category and we said category, let's make a fun category. I don't know why. And we saved this, and we went back down here, and we ran it. Now we got 4 different categories and exits. So if I put in 0, of course, it's going to say a valid number. I can say 3, no products in clothing. 4, no products in wine. This time 5, because of our program, will be the exit.
Can
See
you
how that-
just make a,
What's up?
sorry.
No,
Yeah,
no.
can you just make like another else if to go back to like select the number of department if you hit that um when you hit that level, oh, like 5, because that's the time where you exit, right? So can you just add like another else if so it will go back to the select number of department?
If you mean if they pick the exit number, are you saying can you create an elif that it lets you to that just lets you continue to select a department even though you said exit?
Yeah.
You could do that. I mean, it wouldn't make much sense to probably say exit and then because remember, yeah, you can. I mean, you can do whatever you want. You could, if you were going to do that, you could change this to an you'd have to change right here. But you still have to, the thing is you have to have a way to exit out of it or you, I mean, it's not going to put you in an infinite loop, but this gives you, you'd have to change what the syntax up here. And in doing that, you've got to have a way to get out of the while loop or you're never going to be able to exit the program logically. Of course, you can just control C out of the program or close the terminal, but this is allowing a way to come out of this loop within the input. But yeah, I mean, you can do whatever you want with the if,
Yeah,
the elif,
okay.
and you can do whatever you want with the if, the elif, and the else. This is just allowing you a way to get out. But yeah, I mean, you could.
Yeah, okay, I got it. I was just thinking about the infinite loop. Now makes sense.
Yeah, you're not going to have an infinite loop because this while loop, remember, prompts this input selection. So it's not like it's just running. It's like, boom, stuck here until right here until I put something in. So when I run it, I'm here. So it's select the number of a department. We're sitting right here in the loop. It's not going to create an infinite loop in the sense that it jams up your computer like it just keeps running and running and running. But there, if we took this out of here and made something else, or if we just put while selection not equal to whatever you get -1 or whatnot, you would just keep getting this prompt and keep getting this prompt. But the prompt, the way it's structured, catches a number that's not valid, whether it's 0, 7. It catches if it's not a number in the string. It catches each of the categories. It allows you to exit. That's all that's doing. I mean, all of this really is just providing a way for us to interact with it. The main point that we're trying to get across here is these classes that we're creating, category, the store, the syntax we're using, the init, and this string syntax, this def _string. Syntax that we're using here for the store, instantiating the class, being able to print it. That's all. That's really all we're trying to get across here. All this is just to make it simpler to visualize. Anybody have any questions about that? I don't even remember if this was in the video or not, but if we wanted to, we're not going to do it here, but if we wanted to create something as an optional argument where if they don't supply it, it will simply default to something else, how would we do that? I'll just do
And
it.
the parameters you put equals whatever.
Yeah, so like right here equals unknown. There's no point of that here. It's just something I wanted to point out. So if you give it, this is giving it a default, whatever the parameter is, supplying a default for it. So in this case, I keep hitting. If we went here and we just instantiated the category and we went here, we just have unknown here because that was our default. Like I said, no point of that here other than just to point out that it does allow you to default that. Any more questions about what's going on in this code? I've dropped it in the channel.
I have a question related to the methods.
Yeah, what's up?
So I don't understand why we are using underscore for init, and I think it's the string. And when should we use this? So we usually, when we want to define a method, we just use def and the name and then parentheses. But why and we should use this underscore?
Okay, this, say we were going to make, if you were going to make your own method, these are built into Python. You could make your own method here and we could name it, I don't know, we've got name equals unknown. We could call a method alter def.
Oh,
Alter.
got it. So those are default.
These are part of the Python language.
Okay, yeah, I understand.
Every class you have will have an init. Think of it as this is simply when we instantiate this class, we're calling this init, and this init is where it's taking in the arguments down here, the name. So the init function is simply part of instantiating the class, taking in the arguments that we need. Like I said, in any function in Python, you're going to take in self as your first argument, but you have to do nothing for that. That's just inherent for all classes. You'd have to do nothing for that when you invoke it down here. You can't touch that. It's simply something that's inherent. This is also built in, and it allows when we're saying, remember down here, where did we do it? Print my store. So remember, my store is simply an instantiation of the class store, okay? Get back on this so it's not throwing errors. So we're saying print this object, but because an object, we can print primitives easy, a string, a character, a float that we'll deal with later, a Boolean. We can print those very easily, but these classes are an object. We can't just say print this object. So Let me show you what would happen if we took this string out and then we run the store again. This interrupt. We're going to run the store again, and it should run. And see if we do 0 and say valid number. If we do 5, it's going to tell us get a valid number. The exit still works, but if we run it again and say we select groceries. Now, remember, when we pick groceries, we're accessing this category and we're saying to, you see what we get?
Got it. So
we get that.
Terminology?
What's that?
What's the terminology for this methods?
I'm not sure I understand your question, the terminology.
So this is a default method, right? It comes from Python's own API. We don't need to create it already exists. The init and string.
Init and string and REPR all exist already. A lot of things exist, but yes, these are already exist under the hood and are supplied to us.
Okay, so I'm wondering what they calling this kind of methods, default methods or API methods, and how can I search to see what are the other methods like this?
I think I see what you're saying. So hold on, let me get out of this. So to be sure I'm clear on your question again, you're asking, okay, we've got this init and we've got this str and we have got all of these different methods available to us that are inherent to Python. You're asking where you can get a list of all the different things that are available to you?
Yeah, that's right.
Off the top of my head, I don't know where. It's got to be in the documentation.
I was wondering what they are calling this kind of default methods. Do they have some kind of terminology, some naming, or?
I'm not sure exactly what Python refers it to. Like I said, you've got attributes that we talked about earlier, the attributes being what we're defining, and we've got functions that perform an action like this. So we can define our own functions if we want to, and then invoke them later on. So we could say here, define, I don't know, fun takes in self and word. And then you could say print word. And then you could call it. Where could we call it?
I think they are calling them special or magic methods.
Yeah, I don't, to be honest, I don't know what the, like I said, I don't know what the Pythonic terminology for those are. I would say, I simply always call them built-in methods, but I know that's not the textbook definition of it. If you're seeing that, then certainly that's what they are. I have a feeling it's somewhere in the documentation. That would be a good question to ask in the Q&A, or I'm going to go find out later on, because now I'm curious that you've asked, but I'm unsure what. I just call them built-in methods. Just like, remember, in JavaScript, on a string has a built-in method of length. A list has a built-in method. Like here, when we invoke length and we're taking in this list, that list has a built-in method on it. Remember in JavaScript when we used to be able, we could go back and we could look at all the built-in methods on certain things. It's the same as this. I just don't know the actual name that they call them.
The built-in works for me, but
yeah, I
more
don't.
key is how to find the list, the available other methods. So I'll ask to Brady or.
I guess, yeah, I'm saying magic methods. I don't think that's the name of them, though. Yeah, I think it's called a special method, it looks like, because they're referring to init as a special method in the documentation. Where there is an exhaustive list of those, I don't know, but I'm going to find out.
If I'm spelling his name, pronouncing his name right, Yangrang shared a link. I think it has lots of information. It's on the Slack.
Yeah, I think that was right here, the one that came up. And there's two of them right here that are probably the most common. To be honest, the only three I've ever seen used are size of, represent, RAPR, and the string. And then you got all your attribute stuff. Yeah, there's definitely a lot to this. And like I said, today we're just touching the tip of the iceberg. So to answer that part of your question, yeah, it looks like they're called special methods. Officially, I have a good feeling where I was earlier, that in this class documentation right here, you're going to have most of.
I think you passed it.
Yeah, I saw. I'm just looking to see what all is in here. And it gets into the inheritance. Yeah, it's. Yeah, and like I said, I mean, it's a new language, and there's a lot available in it, and the OOP aspects of it make it that much more. I won't say complicated because that's say bad, but there's a lot to learn, and there's a lot that you're probably, like I said, when I was looking at all those, as I was referring to them, built-in methods, as they're calling them, special methods. That double underscore, yeah, and they keep changing it all the time. That double underscore is also a way, it's a symbolic way a lot of times used in programming of representing something that's private, like a private method in a class. And in this case, they're probably using it because, it's something already built in. It's something you can't change. It's something you can't access from outside of it. But that would be good questions to ask in the Q&A, do some more reading on. I'm going to do a little bit more, but I'm sorry I don't have the direct answer for that right now.
But that was great.
Any questions that you have particularly about the language? This documentation on python.org is long. It's a little terse at times. It's exhaustive, but everything pretty much under the sun about Python is in it. And when you Google around, normally this is the first, second, third thing that'll appear up is the actual Python documentation. But any other questions about what we've done today? Is everybody aware of what they're doing as far as the work today? If you haven't watched the adventure video yet, watch the adventure video. There is a long description in your repo about what you're to be doing the next 2 days with the adventure game. So if you haven't watched the video already, watch the video. If you haven't watched any of the videos and you still got questions about the basics of classes, watch it. If you have any more questions about anything, pose them right now, or I'm going to go ahead and let everybody get going. Remember, like I said earlier, this is a 2-day repo. So you've got time to work on it, but it's a repo that takes a little bit of time and work, so don't put it off. Definitely get started on it. If you haven't, some of you have already added me as a contributor. I think 2 or 3 of you already have. If you haven't done so, please do so. Anything else from anybody?
I'm just curious about the import from the project itself. Because, oh, nothing. Never mind.
You mean like the import I was talking about earlier?
Yeah.
Okay, so look, say if I took all that I was saying earlier, say I took this category, I think right here, I've got it back to where it'll run. Okay, so I was talking about the imports earlier. I'm going to save this on my desktop as category.py. Excuse me. And we're going to save our category class in here. Okay, so now in the same directory that Python is sitting in my desktop, we've got one named category. So we're going to save that. I'm going to go back here. All we would do is say from category, import category, the class that we're going to be using down here. That's all you put. And if you save it, we go to run it again, it runs. we didn't have this line here. Exit, and we tried to run it. You get an error because category is not defined. Make sense? Real close to a lot of the ways that we imported things in JavaScript. And most of the time, all these classes are going to, a lot of times, going to be sitting in different files. And that's what, you know, part of the modularity of them and the ability to deal with them separately and have a clear separation between them. A lot of times, I just put them all in one thing so we could refer back and forth, up and down to them without having to go to another page. Anybody else?
Hey, you mind zipping this file and dropping it in the chat so we could maybe refer to it later?
Yeah, I can do that. And you're talking about this file that I've got open right here?
Or the whole thing?
Oh, you mean both of these pieces, or how are you wanting it?
What was in the category.py again?
Just the category class.
Oh, well, whatever then. Yeah, I guess this one just works.
Yeah, I mean, you need both of them to run the way that I've got it done now, but yeah, I can do that here in a second.
Cool.
Anybody else? You got your videos for tomorrow. You got your repo for today. Add me if you haven't already as a collaborator. If I'm your PM, if I'm not your PM, add your PM. I dropped the code over here. I'll drop this in a zip. I'm going to rename this one real quick. I'll do the video and get the video dropped. Remember the typical 20-minute rule, the help channels, your PMs. Don't forget your workflow, all that good stuff. Anybody have anything else? All right.